Hello everyone, welcome to O2I Advanced Probability. Um, in 1.1, we're going to start with a simple and classical example, coin flips. Okay, so here, this set represents the total outcome or the possible outcomes of one coin flip. H stands for head, T stands for tail. And now we have pH. This is the probability of throwing a head. Let's denote it as P. Well, in most cases, for simplicity, we set P as 1 over 2, which is intuitive. And however, we still, in order to generalize this, we want to denote it as a number or variable P. Okay. Then we have the probability of throwing a tail, which is 1 minus P, because there are total of two outcomes, and 1 is the probability of every outcome adding together, okay, which is 100%, okay? And let's start with a simple question. Say, if we have 5 throws, okay, what is the probability of throwing exactly 2 heads? Okay, now, this is composed of two parts. First, we want to figure out how many combinations are there for 5 throws having 2 heads, exactly 2 heads. Okay, this is exactly 2 heads, which is really important because without exactly, you can have 2, 3, 4, or even 5 heads, and that's not the thing we wanted. Okay, so in total of 5 throws, um, 5 chooses 2, which you can visualize as this. So we have five spots. This is the first throw, the second, and then we have the third, fourth, and the fifth. Okay. 5 choose 2 means to pick 2 spots and um, put them as heads, and then the remaining 3 are just tails. So the this equals 5. Gosh. Okay. 5 factorial over 2 factorial over 3 factorial, reminding that n choose r equals n factorial over r factorial over n minus r factorial. Okay, so this equals it's 5 times 4 over 2, which is 10. So we have total 10 ways to pick 2 spots um, from the 5 throws to give them or let them to be heads. Okay, this is the first step. We have the combinations of having exactly 2 heads. And then we need to figure out the probability. For every outcome, since we have 2 heads, it's P times P. This is P squared. However, don't forget, we also need to calculate the probability of the the remaining 3 um, tails. So the remaining 3 is 1 minus P to power 3. So altogether, we have P to power 3, then 1 minus P to power 3. And that's times the combinations we had. So 5, 2. So this is the result. And if we say, for example, if let's say P equals 1/2, this is equal to 10 times 1/2 squared and 1/2 cubed, which is equal to 10 times 1/4, 1/8, and then equal to 5 over 16. Okay, so this is the probability, and let's generalize it. Okay, let's say we have n throws. right? We want to find the probability of exactly um, k heads. Okay, this is pretty much the same thing um, of the previous example. However, we used n and k to denote the number of throws and the number of heads. So first of all, it's the same. We need to find the total number of combinations of those outcomes, which is n over k. Um, this n choose k is the number of outcomes of having exactly k heads. And then for each outcome, right, we have k heads. So we have p to the power of k, and then times 1 minus p, 1 minus p uh, to the power of n minus k. Okay, so this is our um, probability of having k heads in n throws. Okay, so this looks pretty similar. Let's bring up another thing. It's called the binomial theorem. So let's say with a plus b to the power of k to the power of n. Okay, this equals n choose k. Um, okay, this equals summation k equals 0 to n, and then n choose k times a to the power of k, and then b to the power of n minus k. Okay, this is our binomial theorem, and this can be really useful in advanced probability because we see how similar those two are, right? So if let's transfer this question to another thing. So we have p. We stop. Now we have n throws. However, we don't know how many k's there are. We want to find the probability of having 0 to n heads n throws. What is that? Okay, so we have, let's say k equals 0 to n. This represents the, the sum of all possibilities from 0 head to n heads. Because reminding that each k value is going to be one outcome, the possibility of one outcome, which is n to the power of k. I mean n choose k, and then p k 1 minus p to the power of n minus k. Now we have okay. So this expression means that when we have n throws, okay, this is the definite throws. We have n throws, and we want to find the probability of all possible outcomes, right? It represents the possibility of all possible outcomes. Because we have from 0 head to 1 head to 2 head to n head. Okay, and let's think about the actual coin flip, right? It covers all the possible outcomes, right? Because we can have 0 head, we can have 1, we can have 2, and we have everything to n. And then there's nothing excluded. Everything, every outcome is included in this expression. So by intuition, this expression should equal to 1, right? Because it includes all the possible outcomes. So let's try to compute this. And do we see how those two are similar? Well, yeah, they're basically exactly the same. So This is just binomial theorem. This is just binomial distribution. So since we have in binomial theorem, we have a to the power k and then b to the power n minus k. So in our probability distribution, h is equals to p, and then b equals 1 minus p. So it's the exactly same form as binomial distribution. So we can write a plus b to the power of n as p plus 1 minus p of n. Well, this is just 1 to the power of n, which is always 1. And this is equivalent to our intuition, which is 1. So it does prove that all of our outcomes are included in this expression, okay? This expression. So let's recap. So for finding, let's say, for finding the probability of having k heads in n rows, we first want to find the combination of having k heads, which is n choose k. Then we need to compute the probability um, of having k heads, which is p to the power of k. And then we computed the probability of heads. And then we want also to include the probability of tails, which is 1 minus p to the power of n minus k. Okay, this is our formula for of having k heads in n throws. I mean, exactly k heads. And throws. Remind you that p equals the probability of getting a head, and then 1 minus p equals that of getting a tail. Okay, so this is the formula today, and we actually have several exercises for you. So those three, start with 1, and then 2, 3 are more general questions of 1. So so first, find what is the probability of throwing 5 heads in a row in total of 10 throws. And then once you find that, we still keep um, asking what is probability of throwing 5 heads. And this time, we're asking in total of n throws. And then question 3, we generalize this question into throwing 8 heads in total of n throws. Okay, so these exercises are for you, and thank you for listening.